Hi, thank you, Elastic, for giving me this opportunity to talk at the first community conference about creating a custom track in Rally to benchmark your production cluster. My name is Bertani-Økland, and I'm a chief engineer at Computus. I'm a mathematician and a software engineer working on the domains of machine learning and search. Computus is an IT solutions provider based in Norway. We deliver services and solutions for work processes and collaboration, as well as custom software development, architecture and integration, project management, and consulting. This work was developed to help our customer Entur. Entur provides digital services to the public transportation companies in Norway. So by using Entur's platform, companies may create tickets, inspect, and gather data about sales. They also make it possible for companies to sell tickets on behalf of each other. So this enables travelers to buy tickets to their whole trip in one go, even if their trip involves several legs with different companies. So in other words, Entur makes life for passengers easier. Let's talk about the problem. You have Elasticsearch in production with lots of users. I want you to think about how you would answer the following questions. What changes should you do to your cluster architecture to withstand an increase of X% of traffic on Fridays? What if you add a new feature that requires adding new query types to your typical load? Or how is this new version of Elasticsearch going to perform on my current load? How will your search latency be affected if you change all your, say, double fields with scale float in your mapping? I will come back to this last question. But this is how I would answer them. With data. I personally don't like guessing. I like to be able to experiment, gather data, and reach conclusions based on evidence. So the next question you would ask is, how do we get the data to find the best answer? What kind of data should I collect? What tools can I use? Or should I write the whole thing myself? And on this last question, it's a big no. You will probably make some mistakes and things won't work out as you expect or introduce bottlenecks. It's really a very complex problem. But what we can do is we can use Rally. Rally is an open source benchmarking tool for Elasticsearch developed by Elastic. And it can help you with the setup and teardown of Elasticsearch clusters, with management of benchmark data, with running benchmarks, finding performance bottlenecks, and comparing the results, and also make each experiment reproducible. Here's a functional overview of Rally. And this is by no means comprehensive, because I'm hiding a bit of complexity for you. So this is just the components that we are going to need in order to create a custom track. If you look at the center of the chart, you'll see that everything goes around the concept of arrays. And yes, Rally borrows concepts from the domain of racing, so everything has to do something with racing. So arrays is a benchmark instance. And the definition of the benchmark is done in something called a track. Inside a track, you will find things like this: indices, corpora, which is the data, challenges and operations. And operations are things like create an index, delete an index, wait for green state, make some bulk indexing. The challenges will be like the runtime configuration for these operations, like what's my throughput? How many threads should I use? And the schedule is going to tell it like in which order things are going to happen. You also have something called a track repository, which allows you to share the tracks between your team. There is also something called a pipeline, which is not like the typical pipeline you're used to, but it's something that you can do before and after arrays. So let's say you want to benchmark a certain version of Elasticsearch, and you want to build from sources. A pipeline will allow you to do all the processes before you create your cluster, from building the Elasticsearch version to creating your cluster, and then tear down your resources when you're done after the race. When you run a race, you're going to produce lots of data. You should have a metric. We have a metric store where we can put all this data in. You can choose to do this in a memory store or use Elasticsearch to store your data. And if you choose Elasticsearch, you can afterwards combine it with the power of Kibana to do more analysis on this. There is something else called a car, which is a specific configuration for your Elasticsearch nodes. Like it allows you to define things like the memory size, the heap size, for example. I will not cover this because in this case, we're going to benchmark an existing cluster, which it's assumed to be like production. So how to build a custom track? What you need are the following ingredients. First, one query distribution from production. You need to know also the query types to parameterize. And here, N, it depends on how much you want to resemble your production load. A query type you can see that as a query template. It's like if you have a query and you remove the parameters, and when you end up with, it's your type of query. You need also the search rate for each query type in your distribution. You need to know also your update and indexing rate of your documents. You need one Elasticsearch cluster with a copy of production data, Rally, and one programmer with high attention to detail. You may have the last ingredients, but the first 4 ingredients can be a bit difficult if you don't have a way to keep track of your queries. And one way to do this is to fingerprint your queries. And this is like creating an ID for your query types. And this can be done in your backend, for example, when you're building your queries. Before you put your parameters, the string you have, you can create a hash, and you can log this along with your latency, your service time, and what kind of indexing operations you're producing. This is an example dashboard that we created for Enter, where we can visualize the query distribution over time. And you see the big hashes here are the queries fingerprints. So there are certain type of queries that occur more often than other ones. And you see a big spike in latency also around the 1st of December. Down here you also see which is the max latency in milliseconds for each fingerprint, so that you can identify culprits. And here you see the percentiles of the query latency and the max latency. So to build a custom track, the first thing you need to do is to create a custom track from your data. Then you have to define the operations and the challenges and implement the query templates. When you have done that, then you can run the experiments. So in the rest of the talk, we're going to go a little bit deeper into each of these steps. So let's look at how to create a custom track from your data. I'm assuming that you have a deployment in Elastic Cloud. And to make things easier, you are going to work with the Rally Docker image. Since we're going to work with the Docker image, the data is going to be stored inside the Docker container. So that's why we have to mount some folders from a local hard drive to the container in order to the data to stay in your hard drive before the container disappears. You also need to define the endpoint, the username, and the password to connect to the cluster. And it's really important not to use your cluster, even if it's tempting. Because Elasticsearch Rally, it can create and destroy clusters, right? So if you issue the wrong command, you are gonna have a lot of trouble. Then if you're using Elastic Cloud, it's really easy to produce a copy of your production cluster. So this shouldn't be an issue. The last thing to do to get the data for the custom track, you need to run something like this. AS-Rally, which is the command line version of Rally, create the track, and then you give a reasonable name for the track. You specify the host, which is the endpoint, how to connect to Elastic Cloud, the username and password, and the indices where the data resides. Then you're gonna also point to the output path where you will store the track. And since you have mounted the track to your local drive, it will stay there also. I typically use an alias to do this, to do the correct mappings. There are several other mappings that are important, but I'm not gonna talk about them today. When you have run this, you're gonna end up with the following files in something like this in your folder. The first files you see, my Rally index documents 1k.json, and the bset2 file is binary. It's just the same information, but it's just a compressed version of it. My Rally index documents without the 1k, it's the full data. And the 1k version is because Rally allows you to run in test mode and full mode. In test mode, you will just use the first 1,000 documents from your full data. It will allow you to, when you're building the track, to experiment and see that what you're doing is correct. There is also my Rally index.json, which is just the Elasticsearch mapping definition, and the benchmark definition, which is the track.json. This file can get really big and messy. But fortunately, you can refactor this and extract each component like track.py, which is where we will implement the query templates, the challenges.json, which is where we define the challenges, and the operations.json, where we define the operations. And this is a bit easier to keep track of things. If we look at the track.json file, this is Rally uses Jinja2 as a templating language. What you see in the first line is how do you define parameters. And here I'm using, for example, something called target index name, which is the index name where we're going to put the data. This can be also assigned via the Rally command line tool, so that I can pass this name when running the experiment. But if I don't pass anything else, I will use the default value of benchmark1. And inside my script, since I'm going to use this value a lot, I'm going to put it into a parameter called p_target index name. The reason why I'm adding the p here is that it's clear for me to know which variables I'm using as parameters in the script and which variables come from the command line. You have the indices section where you define the index, the corpora where you define data. And if you see here, I just want to pinpoint to the base URL, because if you specify this one, means that you can pull your data from a cloud storage, like for example, a GCP bucket. You have also some counter variables, which will allow you to tell Rally to verify the validity of the file, the data that you download, and also give you the progress track. Next, we will discuss the operations and the challenges. So you see, we are still in the track definition. So let's define the operations. How does it look like? We have something like delete an index, create an index, wait for green status. But I want to focus on two more complex things, like how do you define an operation that is gonna push data into your Elasticsearch cluster, and sometimes push new data and sometimes update old data. So this is done by using an operation type of bulk, which is bulk indexing. You say which index you're gonna put it to. I'm gonna put just one document at a time, and there will be random conflicts. Why do I want conflicts? Because I want that when there is a conflict with an existing document, I want to update it. And I can also tell it how often do I want to have conflicts, which practically will be the probability that I will update the document. And this is a parameter that I can change. There is something called recency also, which allows you to control, its value, its recency goes from 0 to 1, and it allows you to control how often do you want to hit newer documents with respect to the old ones. So by having a recency of 0.8, I'm telling it that I want to update documents that were recently inserted. And this resembles to how data is being used in production. In the same way, I can define also a search operation. And here I'm defining something called a parameter source. Remember this big string. This is how I'm going to bind a Python function to this string later on. That is going to define the body of the query. But what I can define here is the following five parameters, four. created by ID, organization ID, and start date and end date, because I'm going to use a random date between these dates, and I'm going to use randomly one of these values for each of these parameters when defining my query. So now let's define the challenges. In the challenges file, what we're going to see is that we start by, we're going to define a schedule, is like how things, in which order things are going to happen. And the first things you want to do typically is like delete the current index because I want to start from scratch. And then you want to create the index. Maybe you want to wait for green status and also put in some data so that you have some state. But when you're done with that, then you start the test. And I'm telling it in parallel, I want you to warm up for 60 seconds and then run the benchmark for so many seconds. And this is a parameter I could change. I could also write the warm-up time period as a parameter too, but yeah, that's also an option. Then I define the tasks. And here I want to define the index update operation that I defined before in the operations section. I just called it upsert load. And I can define the target throughput, how many documents per second, how many times per second I'm going to run this operation, and how many clients. The important thing with the clients is like how many threads I'm going to use to produce this data. If you underspecify the client's value, you will see that you're not hitting your target throughput. So you have to try and check. And if you don't hit it, add more clients. That's kind of good. And similarly for the search operation. The last thing that remains is how do you these query templates, right? And this you do in the track.py file. It's a Python file. And what you're going to do is basically define a Python function with this default signature. This is how you send the parameters that you define in the operations file. And this is how you read each parameter, right? I read it from this, I know, if you remember from before. And then I create a random date between this start and end date. And here I can define the body of my query with these parameters. Then the last thing I have to do is to bind, do you remember long string from the operations file, to my Python function so that Rally knows what to execute. This is a critical issue. There is a critical problem here that if you do this incorrectly, you introduce a bottleneck here. So you should remember that this is going to be run in parallel and by several threads. So you want to do things that are idempotent and don't have state. But fortunately, Rally has also a performance profiler that can help you find issues if you have done something wrong here. Well, let's run the experiments then. And then what we want to know is what happens to my search latency if I optimize my mapping types. So more specifically, the question is, I have lots of double fields in my index mapping. And I was thinking, okay, let's replace all of them with scale floats. What would happen if I do that? To run the experiment, we're going to define 3 challenges, which is the insert update, where I'm with a rate of 10 documents a second. And I want 80% of the events to be updates, 20% inserts. And I have 2 types of queries, my top 2 queries that I'm going to run, which are going to at a rate of 5 queries per second. So what I want to know now is how will the search latency be affected? I'll run this for 5 minutes with 1 minute warm-up. And if you want to know more details about where I'm running this, it's here. Okay, so what do we get? This is an example of a dashboard that we built for Entur. And what you see up to the left is the timestamp of each race and an ID. Rally will create a width for each race. When you run a race, you can also tag the race with something more reasonable for you, so that something that makes sense for you. And this is what I did here. I tag it with, for example, full run, not optimization, run 1, run 2, run 3. So this defines experiment where I run the benchmark with the double types 3 times. And I run the same experiment with the scale float 3 times also. And these are the IDs for each of these tags. So this is how I could track which tag corresponds to which ID. Here we see also down below the 25th percentile of latency, and the 50th and the 95th percentile of latency, and the max latency. These are the colors here. And I'm going to show for each race the distribution. I also have my service level indicator of 100 milliseconds. I want to be under 100 milliseconds latency, but I see that the max, at least for all the experiments, goes over. And it's something that is difficult to see here is which of these widths corresponds to which experiment, right? So that's why you have to follow here a little bit. What you see also, this chart is split in 3 charts, 1 for each operation. The first one is the observed load task, sorry, for each task. The other one is the search one, and the second search query. If you have just 2 experiments, it's easy to see them which is best in a way, but when you have many, it can be a bit complicated. So you can choose here just to compare 2 and 2. But to summarize the data for you, what I did is a table where I took the average of the 3 runs for each experiment and just put it according to which operation that was run. And for the insert update, we see that maybe experiment 1 is winning by a little bit. But you see that the difference between the latencies in each percentile, it's not that much. Well, only here in the max latency, you see a big difference. And the same for the other query searches. So what we can conclude here is that the data is still inconclusive because the intervals are overlapping for each percentile. So it's not a very clear cut. But what was surprising for me is that I really was expecting a big difference by changing from double to scale floats. And the data is not showing that to me. But so if you want to conclude, you really have to run more experiments, and then you will get enough data to see the difference here, if there is any. So to summarize, I want you to remember 3 things from this talk. And the first one is that Rally allows you to be more data-driven. It is a steep learning curve, but it is worth it. And you have to remember to run the same experiment multiple times, because you don't know if the numbers you're getting are just because of statistics. So you need to run this several times in order to estimate it properly. Well, that's all I have for you today. Thank you. And if you have the slides, I put also some links where you can follow up more and learn more. Thank you.